February 12th, 2017. 2017, it's been a long time. In September of 2011, the discovery was made, and I remember telling Bill Gates about it. And before I'd even come into the picture, he had been, trash talking mathematical physicist and cosmologist for about 2 or 3 years, maybe even 4 or 5 years, I can't remember. But along that time, I was struggling with my own understanding of why it is that mathematicians were so dogmatic, and why the hell mathematicians were even studying the stars to begin with. What are they doing? Why are they claiming all these things to be true when math is not physics? And then they were looking up at telescopes and trying to figure out with math. These are physical things. It isn't a mathematical understanding here. It's physical. But I finally figured out why it is that math was so popular and why they continue to make up bullshit and some problems that I've noticed. Now, I'm not going to go along the lines of saying mathematical physicists are religious folk, but they do have a lot of similarities, and they are very, very dogmatic in their ways. So here we go. Mathematicians are attracted to the stars and planets because they appear to not change, just like math. The kind of mindset they have is, well, the ancients, when they were looking up at them, they had predictable patterns. They would do the same thing over and over and over and over again. The circles upon circles. They always knew where they're going to rise up over the horizon and come back down, and they were very predictable. So naturally it became a mathematical conquest to see what kind of mathematical rules they could apply to, because with math everything else was predictable as well. With one theorem that could be applied to the same understanding with somebody else who you don't have any contact with. It could be the same thing. It's the same thing all over the earth. It's stable, it's never changing, it's eternal. And that point is the heavens were considered eternal, so it fit the mindset of people who believed in eternal ideas. It fit the priesthood type of mentalities, where you look up at the sky at night and it's the heavens. They're eternal, they're never changing. So naturally the priests became the mathematicians, and the mathematicians these days are like priests, where they believe that there's these eternal, unchanging rules of nature that can be figured out with numbers. But I don't think that's true at all. I think math and physics has a relation just like a horse and a cart. The horse is pulling the cart, not the other way around. The cart doesn't pull the horse. And then in this case, the cart is mathematics and the horse is physics. You understand the physics first, the math comes second. You never put the math in front, because what will happen is you'll start drawing up these weird ideas that have no relation to reality. We'll see that a little later in this talk. Mathematicians like the idea of stability. It is in their personalities. Chaos and unruliness is something they despise, because their math has an impossible time with pure randomness, chaos, and the concept of zero. I've noticed these three concepts: concept of zero, chaos, and pure randomness, that math has a very hard time dealing with. Randomness, in this case, has to do with the orbital configurations of the objects in the solar system, because they want to believe that somehow there's a pattern. There's a pattern of their orbits. We need to figure out why these patterns are showing up. But then, now that they have the Kepler data and all the exoplanet data, they're finding out that the patterns aren't the same. You have gas giants outside of the snow line in our pattern, but now they found hot Jupiters where the Jupiter is way in front of the snow line. That's impossible. So now they're looking for patterns and trying to make things fit inside of a model where there's no randomness. But in stellar metamorphosis, randomness is the name of the game. You never know where the objects are going to be orbiting. You never know. There's no way to predict that, and there's no way to tell by their orbits which ones are more evolved than others. You have to tell inside of the stellar metamorphosis what their orbit, what their evolutionary sequence is based off of their actual physical characteristics, not their orbits, not the mathematical orbital mindset. That's not going to figure this out. You have to actually look at the object you're studying to determine how evolved they are in their evolutionary path. Chaos. They have a very hard time with chaos. To them, it's hard to see that the stars change. So naturally, nothing is chaotic. It's all stable. But things change constantly on longer timescales, and they're just not apparent from our perspective. Look at, for instance, like a rock. Say you could make a rock into a conscious being. From a rock's perspective, trees would appear to be as explosions in the ground. Think of a mushroom cloud of a nuclear blast, and then think of a tree. They look very similar. I don't know if you can tell by that drawing. Right there. You have your nuclear blast, and then you have your tree. But to think if a rock is just sitting there for a long-ass time, maybe a billion years, trees would just, they look like little firecrackers going off. But to us, our perspective, they're stable. They're not going anywhere. Because our scales, our perceptions are very, very limited in the way we view nature. So to take mathematicians, when they look at the stars, they say, well, they're all stable. Of course they're going to appear stable. Of course the planets are going to look as though they're never changing. But we know better. The mathematical perspective is not the superior perspective in this case. Of course, that has to do with deep time. I think I went over that in a previous talk. And last but not least, the concept of zero. I say the concept of zero because to me, zero is not a number. A number is something you give a count of. You can't count zero of something. It's a placeholder. But somehow mathematical physicists, mathematicians, and astronomers have accepted zero as a number when they solve for their equations, thus leading to ridiculous concepts as black hole singularities. If there's no matter in there, if the matter equates to zero matter, there's nothing there. So the fact that they have thought up these ridiculous concepts and somehow everybody has been convinced to believe them, it's a wild sociological phenomenon that we're going to look at in the future and think, wow, let's try not to do that again, because that was absolutely ridiculous. But yeah, they're fantasies based off of their failure to understand that zero is not a number. It's a placeholder at best. Alright, y'all. Made that talk long enough. I've been reading this science book about history of science inside of different cultures, the Chinese cultures, the Hindu cultures. Hopefully I'll find a lot of clues in there. Hopefully I'll find some philosophers or scientists that have figured this out long before I did. And that would be really cool to read. Hopefully they mention it in this book. Alright, take it easy.